Okay, so now let's discuss LCM and HCF in terms of prime factorization. And we will discuss it in terms of prime factorization. So how would we do this? So with prime factorization, to break a number down into its prime numbers, for example, if I gave you 32, I know sometimes in grade 8 they do the ladder method and all of the tree method and so on. But what we would do is, you can use your calculator, right? It's not a very difficult process, but the way you break down a number into its prime numbers, let's say if you don't have access to a scientific calculator, but you should, it's simple. You just take the first few prime numbers, let's say 2, 3, 5, 7, 11, and so on. And then you start dividing this number by each of these prime numbers. So you'll say this. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Right? And you will continuously do that until you get a prime number that is not divisible by this number, and until you get to a point where you stop at 1. So therefore, what this numbers on the left hand side means, it means that 32 factorized into its prime numbers is 2 times 2 times 2 times 2 times 2. So it's 2 5 times. Right? Let's say that you have a number like what can we say? 39. Let's say you have a number like 39. Then you would start with the first prime number, 2. Is 2 divisible by 39? No. So let's work with 3. So 3 divided by 39 is 1, 13. And then 13 is a prime number, so 13 divided by 13 is 1. But you need to remember that 13 is a prime number. So therefore, and you know how to test for a prime number. We discussed that in the first video on the prime numbers. So therefore, 13 divided by 13 is 1. So therefore, we can say that 39 in its prime factorized is 3 times 13. Right, so obviously this process is simplified when you use the calculator. From saying if you do not have access to a calculator, this is the way you would do it, using the ladder method, right? Okay, so now that we understand how to break a number down into its prime numbers, let's discuss the rules involved once we have the numbers broken down. So let's work with the same examples that we had. So 32 and 16. Right, if you break down 16, it'll be 2 times 2 times 2 times 2. And 32 will be 2 times 2 times 2 times 2. Okay, now that we have this, what is the rule if I'm trying to find the LCM between 16 and 32? What is the rule involved here? All right, write this down. Multiply all shared factors. So multiply all shared factors. Shared factors, right? And in brackets, I want you to write common with at least 2 numbers. So it's common with at least 2 numbers, right? So multiply all shared factors common with at least 2 numbers, close the bracket, and unshared factors. So unshared factors, meaning that it's factor from one number only. So basically it's a factor that is alone. You can think of it as a factor that is alone. Right, so let's look at this example. If I have to, there's one more 2 here, sorry. If I have to list or circle or ring all of the shared factors, meaning that it's common with at least 2 of the numbers. See, this number here and this number is common with at least 2. It's common to this and it's common to that. So therefore, this is what we will call a shared factor. So I'm going to show shared factors with a red marker, and I'm going to show unshared factors with a pink marker. Okay, so the shared factors are this 2 here, this 2 here, this 2 here, this 2 here. You see this number, this 2 here? You see this 2 here is what we call an unshared factor, because it is common from one number only. So it's common to one number only. So it's a factor from one number only. It's only common to 32. It's not shared with another number. That's why it's unshared. It's on its own. So now we have to find the LCM between these 2 numbers. It's a product of the shared factors and the unshared factors. And remember, this is what you have to do. You have to take one from each group. So this is how many groups of 2's you have here. You have 1, 2, 3, and 4. So 2 times 2 times 2 times 2 makes up the unshared factors. So that's blue. And you're going to multiply that by this 2 here, which is the unshared factors. Unshared factors, which will be this here in pink. And what you get is 32. So what we can say that the LCM between 16 and 32 is 32. Okay? So that's how you find the LCM between these two numbers. Okay? Now, if you have to find the HCF, what is the rule involved in finding the HCF? So the HCF between 16 and 32. HCF, take only shared factors common to all numbers. Now remember this, we have to highlight this. Shared factors common to all. That's very important. All numbers. All right. So remember, I use the word here, all. Right, I'm going to discuss an example where you will see how this word is, understanding this word is so important. This definition is so important. So looking at this here, what are the shared factors? It's these batches here. It's this batch, that batch, that batch, and that batch. Are they common to all of the numbers in question? Yes, it's common to both 16 and 32. So therefore, the HCF between 16 and 32 will be 2 times 2 times 2 times 2. Now, what I want to do is I'm going to actually give shared factors common to all another color, which is orange, right? And I will discuss an example where this will be important. So therefore, the HCF between these two numbers will be 16. Okay. Now, if I have to go back, I don't know if we did this example. Okay, I did not do the example where we've looked at the LCM between 16 and 32 using the longer approach. But if you can see that the HCF, both the methods give you the same answer. You can see that both the methods give you the same answer. So therefore, you can see two different ways to get the same answer. But this method here with the prime factors is actually a more quicker approach to solving the question. Okay. So yeah, so that's what you need to remember. So let's work with a more complicated example so that you can see how we should actually structure this and write this down. So I'm going to go into more detail about this, the way you should write it and so on. Okay, so let's be a bit more strategic about exactly how we are going to find the LCM and the HCF. So firstly, what I want you to do is to create columns, right? And what these columns are, or the heading of each column is going to be a prime number. And the reason we do this is so that we can lay out the prime numbers in groups. Right? Because remember, we are taking groups, we're dealing with groups and ungrouped prime factors. So it's important that we lay this out properly. Right? You'll see exactly what I mean here. See, with 12 is 2 times 2 times 3. 24 is 2 times 2 times 2 times 3. And 48 will be 2 times 2 times 2 times 2 times 3. Right? So we have to find the LCM between these two numbers, or these three numbers. Right? We will first find what are the shared factors. The shared factors are factors that are common with at least two numbers. So these are your shared factors. These are your shared factors. These are your shared factors, and these are your shared factors. You can see that these numbers are common with at least two numbers. See, this 2 here is common with at least two numbers. There's 3, but we said for shared factors it has to be common with at least 2. Okay, so therefore it'll be 2 times 2 times 2 times 3. So that's the shared factors. And what do we do to get the LCM? We multiply that by the unshared factors. What is or are the unshared factors? It is 2. So I multiply by 2. That's your unshared factors. And therefore, if we have to multiply this out, 2 times 2 times 2 times 2 times 3 is 48. So the LCM between 12, 24, and 48 is 48. Now, if we have to work with the HCF, we said that there's something that we need to remember. And that is the common factors, or the shared factors, need to be common with all. So the shared factors need to be common with all. So from these batches of shared factors, see, this is all shared. All the blue groups are shared. Which of these numbers, or which of these shared factors are common to all? It's only this, this, and this. These are shared factors, but it doesn't satisfy it being common to all of the numbers. So therefore, we have to be very specific with what groups we take. So therefore, it'll be 2, Remember we said we take 1 from each group. It'll be 2 times 2 times 3, which is equal to 2 times 2 is 4 times 3 is 12. Okay, watch this here, right? Remember we said when we simplify or we solve, we want to do so in the best, fastest, and simplest way possible. See all these words here? If you remember degrees of comparison, from English, the last degree, like we say good, better, best, big, bigger, biggest. These are where, see even this word here, lowest, highest. What is the best? What is the highest number that can divide into all of these numbers? Why? There are other numbers that can divide into 12, 24, and 48. Right? Remember we said there are many factors that are common to all. But what is the highest number that can divide into 12, 24, and 48? Because if I can extract it, right, this is what we will do in factorization. If I can extract 12 from here, and extract 12 from here, and extract 12 from here, then I can rest assured that whatever I have within brackets will be in the simplest way possible. I'm going to link all of this to factorization because we want to extract the highest number so that we can get the simplest answer. And that is what we are trying to do. Or we're trying to look for the lowest number so that when we add fractions together, we have no remainders at the end. It's the lowest number. There are other numbers that we can use, but what's the lowest number? Right, so this is how everything will start to link. And because all we're doing is simplifying and solving. And this is why maths is not hard when you understand it like this. Okay, so yeah, so that's about it. Let's discuss another example so you can see how everything fits. Okay, so now let's look at a different example. Let's say that we have 12, 48, and 72. Right, so what's our first step? First, create these blocks, these columns. Right, these columns basically represents the prime numbers, the first few prime numbers. And then in these prime numbers, we start filling them so that we put them into different groups. Because when we start ringing the shared and the unshared, we need to have them categorized and written neatly. Okay, if you can write it neatly without these columns, then that's good. But if you want a more systematic and a neat approach, then just follow what I'm doing. 12 is 2 times 2 times 3. 48 is 2 times 2 times 2 times 2 times 3. Right, and 72 is 2 times 2 times 2 times 3 times 3. So what is our first rule? To find the LCM between these three numbers, so the LCM between 12, 48, and 72 is the following. Find all of your shared factors. So what is a shared factor? It's factors that are common with at least two of the numbers. So see, this 2 here is common with at least 2 of the numbers. It's common to this and this. This 2 here is common with at least 2 of it. See this 2 here? It's also a shared factor because it's common with 1 and 2. So at least 2, therefore it is. This 2 here cannot be a shared factor because it's common to only one number. So therefore it's an unshared. This 3 here is common with at least 2 of the numbers. So this 2 here and this 3 here are unshared factors. What do we do next? We multiply shared and unshared. So it'll be 2 times 2 times 2 times 3. So I'm taking 1 from each group multiplied by 2 times 3. So this first part makes up your shared factors. And this part here makes up your unshared factors. Okay, very simple. Now if you have to multiply this, you get 144. If you have to multiply this, you get 144. Now let's do the HCF. This is why I said you have to be very, very careful with the definition. Right, look at your definition for HCF. I said you must take shared factors that are common to, and I highlighted this word, all of the numbers. So if you look here, all of the blue blocks represent shared factors. Is that correct? Because we said that shared factors are common with at least 2 of the numbers. So all of these blocks here represent numbers or factors that are common with at least 2 of the numbers. But the question is, from these blue blocks, which of the factors are common to all? It's this one here is common to all. This here is common to all, and this here is common to all. See, this group, this shared factors group is not common to all because it's missing a 2 there, right? Because that's how 12 is factorized. So therefore, what we can say is that the HCF is 2 times 2 times 3. It's only this 2, that 2, and that 3, not this one here, because it's not common to all. And your answer is 2 times 2 is 4 times 3 is 12. So the HCF between 12, 48, and 72 is 12. Okay, so that's the reason why it's very important, because you need to see these things, right? It has to be common to all, right? It has to be, firstly, it has to be shared factors, which we highlighted in the blue, but then you have to go a step further and check whether it's common to all of the numbers, okay? Then I want to just give you a small trick question here. Let's say you're given 5, 12, and 10. 5 can only be factorized as 1 times 5 because it's a prime number, so I'll put it in there. 12 can be factorized into 2 times 2 times 3, and 10 can be factorized into 2 times 5. If I have to do the LCM for these numbers, this will be shared, and this will be shared, right? Because it's common with at least 2 of the numbers. It's common to this one number and 2 number. It's 5 is common with this one number, and this is the second number that it's common with. So therefore, that'll be the shared. The unshared will be this 2 here and this 3 here, because it's common to only one number. Okay. And now I have to find the LCM between this 2. It'll be 2 times 5, which will make up your shared group, multiplied by the unshared, and therefore we get 2 times 2 is 4, 4 times 5 is 20, and 20 times 3 is 60. So we get 60 there. Okay, and then if you have to find your HCF, we said that we have to find shared factors that are common to all. So looking at these blue groups, are these shared factors common to all of the numbers? No, it's not, because we are missing a 2 here and we are missing a 5 here. So therefore, technically, the HCF between these two numbers is 1. Technically, why? You see, if you go back to the other approach, let's go back to the other approach. See, 1 will be in all the groups. So therefore, 1 will be in all of the groups. So therefore, if we are looking for a factor that is common to all of the numbers and it's the highest, all of the groups will have 1. Okay, but we can't actually do anything with that. So we can't actually simplify it. When we start dealing with factorization, we can't actually simplify a question that will have 5, 12, and 10 in it. So therefore, we'll say that it's 1, right? It's just 1, because you have to factorize it. For 5, you'll only have the factor 1. For 12, we'll only have the factors 1, 2, 3, and 4, and 12. And for 10, we'll only have the factors 1, 2, 5, and 10. And therefore, the factors that are common to all is 1. And the highest to all, so this will be 1 and 5. So the factor that is common to all of the numbers and is the highest is 1. So therefore, the HCF is 1. So using this approach here, you would have said that there's no HCF because there's no factors common to all of the numbers. There's no shared factors common to all of the numbers, but it's actually 1. Right? So that's what you just need to remember. That's like an exception to the rule. Okay, so now you fully understand. You should fully understand all of these topics, right? What I want to do next is I want to discuss LCM and HCF using prime factorization, but with variables. So how would you do it when you have variables in the question? For example, what is the HCF between 20x squared y 4z and 100x to the power 4y squared? What's the HCF between these two expressions? And what's the HCF between these two? What's the HCF between these two expressions, and what is the LCM between these two expressions? That is something that we will discuss in the next video. But you will see that, and once you understand this, then you'll be able to solve any question. It's very, very simple. In under 5 minutes, I'll be able to explain this. Same process, just one thing that's different there is we're adding the variables. Okay.